Hi, welcome back to the brain vascular system discussion, whereby today we are talking about the vertebrobasilar system posterior circulation, which is made up of the vertebrobasilar system, the vertebral artery, and the basilar artery. So join me as we are going to trace the journey of the vertebrobasilar system as it goes to supply the brain. So let's go. So the posterior circulation is made up of the vertebrobasilar system. Remember, we had anterior circulation, which was contributed by the internal carotid, bilateral internal carotid artery. So today we are talking about the posterior circulation, which is made up by the vertebral artery. So we have the bilateral vertebral artery, which are the branch. The vertebral artery is the first branch of the subclavian artery. So the very first branch of the subclavian artery would be the vertebral artery, and then we have the bilateral vertebral artery on either side. So we have the right side, and then we have the left side. So after they branch from the subclavian artery, the vertebral artery, they will ascend to the brain, but they will ascend to the brain using the transverse foramina of the upper six cervical vertebra. Remember, one among the features of the cervical vertebra is that they have foramen on their transverse processes. So these processes, we call them transverse foramina. This foramen, we call them transverse foramina. So they use the transverse foramen of upper six cervical vertebrae, because if you count, you see this is number 1, number 2, number 3, number 4, number 5, and number 6. The transverse foramina of number 7 is usually not used. They are usually typically not used, but in some anatomical variations they can be used. But what we know is that from cervical number 6 all the way to number 1 are used by the vertebral artery as they ascend to the brain. So on reaching the upper part of the the first cervical vertebra, which is atlas, the two vertebral artery, they join together to form the basilar artery. So this is what I'm saying, that we have this we have this vertebral artery, and then after reaching the first cervical vertebra, which is the atlas, they join the contralateral vertebral artery to form the so-called basilar artery. So they form the basilar artery. So the basilar artery is formed by the combination, or by the confluence of the left vertebral artery and the right vertebral artery. They form the basilar artery. So this is what I was talking about. Like we have the left vertebral artery, and then we have the right vertebral artery. On reaching, after traveling through the transverse foramina, they combine together. They form something like a confluence, which is the vertebral, which is basilar artery. So this is the basilar artery. So, but before they combine to form the basilar artery, they usually give some branches. So the vertebral artery also gives some branches before they combine to form the basilar artery. So one of the branches of the vertebral artery, maybe you can see in the second slide, in the following slide, but we have this anterior spinal artery. So we have this anterior spinal artery, which is given by the contribution of the two vertebral artery, and then we have single anterior spinal artery, and then we have the posterior inferior cerebellar artery, the posterior inferior cerebellar arterial, so the so-called PICA. So this PICA, and the PICA will also give a branch here, which will be the posterior spinal artery. But I think we'll have this one. I think we'll have this. Yeah, I'll show you the branches, these branches, little branches, but that's the summary. That we have the posterior inferior cerebellar artery, and we have the anterior spinal artery. The posterior inferior cerebellar, the PICA will give rise into the posterior spinal artery. So as after they enter the foramen magnum, they combine to form the basilar artery, and then this basilar artery will travel. We lie on the surface of the pons. Remember, on the pons we have the basilar groove, so we have the basilar groove at the pons, and this groove will be like occupied by the basilar artery. So the basilar artery will supply a lot of structures, almost all of the posterior cranial fossa. Anything that is found in the posterior cranial fossa would be supplied by the vertebrobasilar system. So that includes the pons, the medulla, pons, the cerebellum, and everything, the occipital lobe, and then everything behind that will be supplied by the vertebrobasilar system. So the vertebrobasilar system will supply almost all the posterior cranial fossa structures. So structure in the posterior cranial fossa, and you see, it will terminate after we talk about these branches, but it will terminate by forming two terminal branches, which are the posterior cerebral arteries. So these are the branches of the basilar artery. And you see now the basilar artery starts from here, and then we have the very first branch, which is anterior inferior cerebellar artery. So that is anterior inferior cerebellar artery. That would be this one, the anterior inferior cerebellar artery. And then after the anterior inferior, not think, guys, that the anterior inferior cerebellar artery, the AICA will give rise into labyrinthine artery. So the labyrinthine artery, which is the internal auditory artery that goes to support the inner ear, will come from AICA and not direct from the basilar artery. So we have this AICA, which gives rise to gives one of the branches, the labyrinthine artery. And then on either side, so we have on this side and then on this side, and then we have small branches that we call them pontine branches or pontine arteries. They, as the name, they go to supply the pons. So the pontine artery will supply the pons, and then we'll have another branch here, which is superior cerebellar artery. So if you are tracing from this picture, you will see this is the superior cerebellar artery. So we have the pontine branches, we have anterior inferior cerebellar artery, we have the pontine branches, and then we have the superior cerebellar artery. After superior cerebellar artery, the basilar artery will bifurcate by forming two terminal branches, and that would be the posterior cerebral artery on either side. So the posterior cerebral artery on this side and the posterior cerebral artery on the other side. So those are the branches of the vertebral of the basilar artery. So that is a branch of the basilar artery. So why is it important to study about the posterior circulation? Well, we know the most of the structures in the posterior cranial fossa are supplied by the vertebrobasilar artery or the vertebrobasilar system. So we can have some, when we have blockage of basilar artery somewhere, we will have diminished blood supply to the brainstem, and then we know how the brainstem is important. So we can have pathologies or presentations of loss of consciousness, the impaired level of consciousness, deficiencies, cerebellar dysfunction, because it also supplies the cerebellum. We have some these symptoms like the locked-in syndrome, then the top of basilar syndrome. They are all associated. They are associated with the blockage of the basilar system. While I know that we cannot talk about this, the locked-in syndrome, the top of basilar syndrome at this point, but I wanted to correlate, like when we have damage to this artery, we know that in the posterior circulation, including the brainstem, the whole of the brainstem, the cerebellum will be affected, and also the occipital lobe. But you will need to connect them clinically. So that was it from vertebrobasilar system. Stay tuned, as soon we're going to reach the cycle of Willis, and then the journey continues. So see you next time, guys.